been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is lesson 3.5, write and graph equations of lines, also an algebra review. So linear functions are functions that have a constant rate of change. In other words, they are straight lines when you graph them. There are three forms of a linear function that we can write an equation for. Standard form is ax plus by equals c. This form is really easy to find the intercepts from and then graph from there. Slope-intercept form is y equals mx plus b. This is the one that most people remember. This is the one that we use probably most often. The slope is m and the y-intercept is b. And so this is easy to graph from. So if you have this equation, it's very easy to graph the line. But this is not easy necessarily to write in. In other words, if I have information about a line and I'm trying to write an equation, this may not be the best option because if I don't know the y-intercept, it makes it a little bit more difficult to use that. Though you can, and I'll show you how to do that. Point slope form is y minus y1 equals m times x minus x1. x1, y1 represents any point on the line. So if you know a point on the line, you can plug those in there. M is your slope, so you have to know your slope. Remember, if you know 2 points, you can find the slope. And so this is really easy to write an equation from, given even just little information. So we're going to use all three of these in our examples. So letter A says, write the equation of the line that is parallel to the line y equals 3x minus 6 through the point negative 4, 2. So if I need it to be parallel, then my slope needs to be 3, because that's the slope of my original equation. And the point that I'm given is negative 4, 2. So what I'm going to do is I'm going to actually use slope-intercept form to find my y-intercept to then get the equation of the line, because right now I don't have a y-intercept. So what I'm going to do is I'm going to plug in this guy for x and this guy for y. So 2 equals, and then my m is 3, my x is negative 4, and now what I'm doing is I'm solving for b. So 2 equals negative 12 plus b, add 12 to both sides, so 14 equals b. So my equation is y equals 3x plus 14. That is the parallel line to my original line, and it goes through this point, negative 4, 2, if I were to graph that. Write the equation of the line that is perpendicular to the line 3x minus 2y equals 8 and through the point 5, 2. Okay, well, I need to find my slope first. So I need to rewrite this in slope-intercept form. So I'm going to subtract the 3x on both sides. So negative 2y equals 8 minus 3x, divide by negative 2. So y equals 8 divided by negative 2 is negative 4. Negative 3 divided by negative 2 is positive 3 over 2x. So what is my slope? My slope of my original line is 3 over 2. So the slope of my perpendicular line needs to be negative 2/3. That's going to be the slope of my perpendicular line. And that line goes through this point. So now I'm going to use point slope form. Y minus y1 equals m times x minus x1. So y minus y1, which is 2, equals m, which is negative 2/3, parentheses, x minus x1, which is 5. So if I did not specify what form I needed the equation in, that would be an acceptable answer. But just for practice, let's go ahead and write down or simplify this to get y by itself. So I'm going to distribute first. Negative 2/3 x, negative 2/3 times negative 5 is positive 10 over 3. Then we add 2 to both sides. So y equals negative 2/3 x. So 10/3 plus 2. Well, 2 is the same as 6 over 3. So this would be plus 16/3. If you don't believe me, do it for yourself. So again, both of these they look different, but they represent the same line. So if I don't specify what form I want the answer in, then you can just leave it in point slope form. That's fine. All right, so for C and D, we're going to graph the line, just a review of how to graph lines. So it says graph the line y equals negative 3x plus 6. So my m is negative 3, and my y-intercept, which is b, is positive 6. So I'm going to plot the point 6 first on the y-axis, and then I'm going to move with my slope down 3 over 1. Remember, when the slope is a whole number, then the rise is that number and the run is 1. And then I'm going to connect my dots to make my line. Now, example D is in standard form. So remember I said it was really easy to find the intercepts in standard form. So 3x minus 2y equals 8. So if I plug in a 0 for y, then this cancels, and x equals 8 over 3. And if I plug in a 0 in for x, this cancels, and y equals negative 4. So my y-intercept is negative 4. And my x-intercept is 8 over 3, which is a little bit less than 3, because 9 over 3 is 3. So I'm just going to put it right about here and draw my line through those 2 points. You could also rewrite this in slope-intercept form and graph it that way, but finding the intercepts is a lot faster. Last example, we're going to graph. This is in point-slope form. So my slope is 2, or 2 over 1, if that helps you. And what do these numbers mean? Remember, this is my x1, y1. So my point, remember the formula is y minus y1. So that means my y1 is 4. And x minus x1, well, but that's a plus sign. So that means my x1 must be negative 5. So I'm going to plot that point first, and then I'm going to move from that point with my slope. So I'm going to go up 2 over 1. Or down 2 and to the left 1. And I can draw my line from there. Now you can see that my y-intercept is going to be a fairly large number. Okay, it goes, obviously reaches up higher than what I have shown here. And so again, if you wanted to, you could rewrite this in slope-intercept form. But again, that's not necessary. Take the information they give you and use it.